I'm live. How exciting is that? I wonder if people can hear me. I've just discovered that having two screens means I'm either looking at the wrong screen or I'm looking at the right screen, and I don't know which is which. But anyway, can you hear me? Sort of working on the assumption you can. Lizzie, yes, we're live. Can you hear me, Lizzie? Just need to know. Okay, I'm assuming it's all working. Yes, we can. Thank you, James. Okay, let me tell you about myself. I'm Rory Wilson. I'm a zoologist. I'm a professor in Swansea University. So that means I lecture undergraduates, supervise masters, PhDs, stuff like that. And I study animal movement, as it says in the blurb on me. And I'm lucky enough to have done that in Europe. Email, just in case any of you wondered what that was. Done it in Europe, the far and Middle East, Africa, Americas, Australia, even Antarctica. So that's a cool thing. And if you like travel, it's a great thing to be an animal movement person. Let me just put it down so you can see me a little bit better. Not that you need to. So what is animal movement? The first thing to say is that, people might think of animal movement being an animal going from here to the shops, but actually animal movement's everything from like the twitching of a fox's ear or waving of a moth's antenna to an animal migrating across the globe, a shark swimming from Australia to Indonesia a mile underwater or whatever. It's all animal movement, and it happens across lots of scales. And it's a really exciting area, and there are really good reasons to study animal movement. I'm not going to tell you about those just at the moment. I'll tell you later. But what I will tell you is about some of the problems of studying animal movement and how I got into it, really. And that was when I was doing my PhD, lucky me, to do a PhD on African penguins in South Africa. Yes, there are penguins in South Africa. And here, there we are. And I was studying their marine ecology. So what do penguins do at sea? And my supervisor, John Cooper, said to me, off you go. You're staying on an island with penguins, 14,000 African penguins in Saldanha Bay, and for a year, and come back and tell me something about what they do at sea. So off I went to my island. I thought, well, that's great. Lots of fun with the penguins, but it's a little bit irritating because in the morning they all jump in the sea and swim off. In the evening they all come back, and they don't tell you what they've done, where they've been, or anything. And in those days, which was many thousands of years ago, there was no way of finding out what those penguins were doing. So, initially I got on some boats and I tried to follow them out to sea, and I discovered how easy it is to get seasick, especially in the sort of Cape region of South Africa. And it was massively frustrating. Penguins don't like to be followed by boats anyway. Why would you? And spend most of their time underwater. So what do you do? So I decided that I was going to have to put some technology on penguins that would tell me what they were doing post hoc. In other words, something to record what they were doing and then look at it afterwards, figure it out. And so being a PhD student, didn't have any money. So this is what I did. I've been grubbing around in my office to find some old technology that I used. So let me just explain this to you. If I do this, you can sort of see maybe there. Let me show you what this is. This is one of the first devices I invented. And it's made of a syringe, just an ordinary 5 millimeter or milliliter syringe, or is it 2.5? Anyway, cut the ends off. So I've got a tube, and then I went and bought some piano wire from a local music shop, and I wound it into a spring, like a compression spring, like that. And that's this. I don't know if you can see it very well. There's a spring in there, and I attached it to one end, and it was free the other end, and I attached the other end to a bung, which I made out of a buoy that I found on the beach. And if you do that and you stick it on a penguin like this, here's a penguin. Need a penguin. Here's your penguin. You stick it on a penguin's tum, and the penguin swims through the water whoosh, like this, then what happens is that bung gets pushed back. Can you see that? It gets pushed back by the pressure of the water from the bird swimming along. The faster it swims, the more the bung gets pushed back, and when it stops swimming, it bounces back to the original position. So that's all very good. So if you could swim alongside a penguin, you could look at where that bung got to after you'd calibrate it and say, this is how fast it's going. Of course, no one can swim alongside a penguin, most particularly if the penguin doesn't want it. So I needed a system to record that. And what I did then, I'm not going to just bore you with lots of details, but it does illustrate how, if you want to be a biologist, a little bit of use, chemistry is useful, physics is useful, that sort of thing. See that? So can you see the hole there? That's a little hole there. So there's a hole there, and in that hole I put some radioactive phosphorus. And that radioactive phosphorus then emitted a beta particles through the housing and onto a film that I strapped over the top in black polythene so it didn't go off. And then I could look at the density on that film and the position on the film. And from the position, I could tell the speed of the penguin. And from the density, I could tell the time it spent at that speed. So using that, I could put it on a penguin. Penguin would jump in the water, come back in the evening. I could say, you've been traveling at 7.7 kilometers an hour for most of the day, reaching maximum speeds of 13 kilometers an hour, whatever, and you've traveled a total distance of 30 kilometers or whatever. And that was, for me, that was game changing because no one knew how far penguins went. You can get an idea how far can they go in a day, but even so, to measure it directly. So that was the first aspect that I looked at, what animal movement was, and a dimension, which was speed, and from that, distance. And so that's one dimension. Of course, if you're working on penguins, a really important dimension is depth. How far down do they go? And again, everyone knows that penguins dive incredibly deep these days, but in those days, nobody knew how deep they dived. In fact, to the point that I had someone come out and visit me on the island, and he was working on little penguins. And I said, well, what do you do in your research? And he said, well, we want to follow them out to sea. So we tie their foot to a piece of string and tie the other end of the piece of string to a balloon, and they swim out and we just follow the balloon. And I said, oh, how long is the piece of string? And he said, well, we thought 11 feet. Well, for those of you who are in the modern world and not in the Rees-Mogg world, 11 feet is just over 3 meters, and that's ridiculous for a penguin. That's like putting you in the bath. And I said, oh, well, I need to tell you about how deep these penguins are going here, the African penguins. And he said, what's the deepest? And I said, well, so far, 130 meters. So how much string do you need? Anyway, I used the same principle to find that out. And here it is. Went into that, again, no money, went into the dive shop and said, what sort of depth gauges have you got? And they said, well, this is a depth gauge. And cheapest you could get, $5 or something. And this is just a capillary tube with air inside it. And if you're a diver, you can't even buy these, I don't think, these days. If you're a diver, what happens is you go down the water column, the water forces itself in one side of this tube and compresses the air in the other side. And then when you go back up the water column, the compressed air just pushes the water back because of the pressure change. And as a diver, you look at the interface. I should turn this email and announcements off, really. Anyway, it's good that you know I'm having an email. What's the most fascinating behavior you've recorded? Albatrosses spinning to catch food. That is the most fascinating thing. Wandering albatrosses, spinning. I'll just put this back up here. Albatrosses. We never knew how albatrosses caught food, and it's been a real problem to figure out how they catch these big squid, which are difficult to catch. And a wandering albatross, big bird, 12 kilograms, 10 kilograms, but they're a bit like a goose. How do they even catch them? And we discovered that they were sitting on the surface of the water at night in areas where there's a lot of phosphorescence, bioluminescence in the sea, spin around in a circle, kicking the water, producing a ball of light, and the squid come up to the light and they say, oh, it is beautiful, I must go to the light, like a moth, to a flame. And they go to the light and the albatross says, dinner has arrived, sort of thing. So that's probably the most fascinating behavior. Do you have any advice for young people wanting to study animal behavior? Yes. If you want to study behavior, a couple of things. Firstly, study biology. You do a lot of stuff at school that might not seem relevant. And secondly, pay attention to physics and maths and chemistry, because you never know when it's going to come in handy. I mean, it's really, really helped me. Anyway, to cut a long story short, on this thing, I used, very quickly, here's the device. I used this to figure out the time penguins spend at depth. And then my father said to me, why are you playing around with radioactivity? Use light instead of radioactivity and record it with light on a film. And that's what I've done. This is a thing that records. This is a bigger syringe, and I just had, instead of a radioactive particle emitting beta particles. I just had a little LED that emitted light, and I recorded the light on the film. Same principle. And I went from there through all sorts of other devices, like this one, for studying not just the depth and the speed and the distance, but also the direction that penguins swim in by using lights and a little compass, little miniature compass. There it is, made. And this stuff became more and more fantastically sophisticated with time. And today we've got to a stage whereby we have amazing technology for animals. So we have things like this, which is a thing that records. Let me just show it to you in perspective. This one was actually designed for a whale shark. This is my whale shark, in cod we trust, and it just gets pinned to the dorsal fin, and this records 400 data pieces a second using accelerometers and magnetometers and depth and temperature and all this type of thing, and then it just pops off and then we catch it at the end of the day. And just to put it into perspective, this is the new smallest tag we have. Look at that little baby. We call it Alice. This is all done by Mark Holton. Look how small that is, and that same device will record 400, 800 pieces of data every second on something that's small enough to carry it, or big enough to carry it. So that's where we are today. And just so that people appreciate, there's a lot of the technology these days, which has now gone from being really clunky, recording stuff on film where you just summarize the data, to really high-tech stuff. It's partly driven by your mobile phone. So because you want lots of information like counting your steps on mobile phones, then we can use that technology in animal technology. So, for example, I've actually got this open. So I thought I had it opened, and now there we go. Let me just show you accelerometer analyzer. Just open this up because this now demonstrates what's going on. So back down to the board. You can get these on your phone. This is just a thing that measures acceleration in 3 axes. And if your phone is not if your animal's not moving, then the signal's stable. If your animal starts to move, then depending on the direction you move it in and how much you move it and all the rest of it, the signal changes. And it's obviously quite complicated, but it doesn't matter because the signal changes, the baseline of the signal changes. And we can use that to tell us all about animal behavior and indeed how much energy animals expend doing the things they do. So it's really fascinating. I will say that I didn't know how long 20 minutes was going to be to talk about this. I can see I've already been speaking for 15, but I will show you this. I sort of this is just a small selection of some of the stuff that I brought in to show you because I've been developing tags and putting tags on all sorts of crazy animals for a long time. Though I will say, without any question, the most fascinating and amazing animal is the penguin. All right, so enough of that. Why is animal movement important? Well, the first thing is, I don't want to diss plants or anything, but if you're a plant, whatever happens, you're stuck, right? So you're a tree growing somewhere and it floods. You're not going to say, well, I don't like floods, I'm going to move. You can't do it. The closest you can come to moving is scattering seeds and stuff like that. But animal movement's really important because it tells us what animals think, what's important to them, what's not important to them. And perhaps the best way to understand that is to think about humans, right? So your life, where you move to, what you do. If you could imagine that someone could, and we can actually using this technology, we could monitor everything. We could see you go and you get hungry and go and get an hamburger. You go to the fridge, you go to the shops in times when you could go to the shops. You sleep, you play, you drink, you interact with others. All these things we can record. And because you do them, are there some species you'd still love to study? Yes, swifts, and we're going to do it this year. So how about that? Swifts, European swifts, and alpine swifts, really crazy birds. And so looking at the way animals move tells us what they think about the environment and what's good and what's bad. If something's bad or there's a reason not to be in a place, they'll move from that place. If something's good, they'll move towards it. And so they tell us how they feel in the way they move, but also in the same sense that if you watch people, I do this at an airport, sit in an airport and you watch people walking past you in times when airports were open, and you can tell what sort of mood they're in by the way they walk. If they're happy, they go, beep, beep, they've got a particular way of walking. If they're sad, then, or if they're in a hurry, they all walk in a different way, and animals do the same thing. And the technology we put on them allows us to tap into that. And that's a really exciting thing because it tells us about mood and what we call internal state of these animals. And so why is any of this important? Well, we're animals that are operating on a planet that is hugely changed by man. I don't know if you saw this recently. It was a thing on the BBC saying that the amount of material produced by man, including roads and buildings and was equal to the biomass of living animals on the planet. Now, it actually exceeded it. Just goes to show how much of a footprint man's leaving on the planet. And of course, animals were here before us, they're with us, and they have to deal with that. So putting this sort of technology onto animals and finding out what they do, how much energy they expend, the places they like to visit, the places they like to avoid, how much time it costs them to do things is really important for managing them or for making their own life better. So things like how do animals react to roads? You never think you're driving along a road at night. You never think you might be putting a badger off when it's by the side of the road. Never mind badger kills. I mean, what about badgers even near roads? What are your chances of being hit by a wind turbine if you're an eagle? I mean, hit one of those blades, ruin your whole day. I mean, eagles, a long-lived species. How hard do penguins have to work now that so many areas of the planet are being overfished compared to when they weren't being overfished? Well, a lot of the answers to what was it like when they weren't being overfished, we can't answer now. So there is a reason to study animals in pristine or more pristine places. Does ecotourism bother whales and whale sharks and things like this? But I mean, there's lots of people like to get out there, and like in Australia, in a place called Ningaloo Reef, you can get in a boat and you pay money and then you can swim with whale sharks. Maybe that's fine. It probably is. But how close can you get? How much does it really bother them? All these sort of things. Encroachment on their life, it's as much their space as it is our space. Is the things we do, how much is it affecting them? What about barriers in game parks for lions? You put a barrier up and you say we're protecting them, and then if you're a lion, you say, well, I didn't want to stop there, I wanted to go on. And how does that change your ability to hunt? One thing's for sure is if you're an antelope being chased by a lion or a cheetah or something, you come against a barrier, that's a pretty good way of being convinced that it's not a good idea. Lots of predators catch animals against barriers. So the cool thing about this high tech on animals, we have a device which we call the daily diary, which you put on and it just records frantically everything that these animals do. And you can get it back and it's like a diary that's written by these animals. And it's just an amazing privilege to be able to read it. And it's also great to think that some of the information can be used to help protect them or point out where there may be areas of problems for them. If there's a take-home message, if you want to study this sort of thing, there's never been, would you say a zoology degree or environmental science degree is more relevant for a career in conservation? Absolutely. You want to conserve something, if it's an animal, then a degree in zoology, some sort of biology. If you want to conserve plants, and of course they need conserving as well, then a botany or biology degree, but definitely a degree in zoology is important. But the fun thing about it is that all the developments and all the advances that we've made as people have enabled us to have this incredibly powerful technology, and you can make a difference. Study the right things, you can be putting them on. Here's a question here. I have with girls and brownies, and we're looking at birds. Looking at this month, is there a migration story that must capture their imagination so some of them stay interested beyond our meetings? Well, I would say perhaps a really important thing is to change people's mindsets. Because one of the things we say is you sit in the garden and a bird flies over and you say, what was that? You say, that was a swallow. well, yes, it was a swallow, but never mind the fact that it was a swallow, it still is a swallow. And we tend to have this very limited mindset of it's gone from our sight and therefore it's sort of gone. No, it hasn't. That swallow is still doing its thing. And to make people understand that, I mean, it's quite difficult, but I remember being in Kenya and watching the zebra and having European swallows flying over and catching flies in and around the zebras, and just thinking, one of those swallows, that one there, could be the same swallow that flies around Swansea. It's that tiny little bird's gone that distance. It's just amazing. So if you could get people to project their mind over the vast tracts of distance that these animals are covering, how long will it take you to walk to Kenya if you're a small child? You know, and to remember that it's not a case of it was a swallow, it still is a swallow, and it'll be a swallow tomorrow and the day after and the day after. So yeah, I can see I need to stop. I've overstepped my time, but the cool thing about this is if you're into high tech, and if you've got a phone, then obviously you're sort of into high tech. If you're into high tech and you want to save the planet, there's a lot of stuff that needs saving, and the more we mess it up, the more it needs saving. And if you get into this sort of thing, which is really the future, many species will thank you, or at least they would if they could. All right, there we are. I think we got to the end of the. What do I do now? Do I just turn it off? End stream? It's been lovely to know that at least 2 people have listened. Emily D, what's the biggest animal you've tagged, and in what did you learn? Oh, whale shark. A whale shark, they get up to 20 meters long. That's a really big animal. And what did we learn? We learned that they use, for example, there's so many things we learned from whale sharks: how they catch prey, the times they spend at depth, from a point of view of their conservation, what levels in the water they occupy, and therefore how likely are they to be hit by a boat, because they get lots of boat strikes on whale sharks that injure them, and so on and so forth. So yeah, I've not been very good with looking at the questions, but anyway, I hope that it found some resonance with some of you, and it was fun being here. This room is really hot, by the way. I just thought I'd let you know, because if you're cold somewhere, I'm hot. Okay, bye.